Good day. So we will be talking about the principles of mathematical induction. So these principles of mathematical induction, it is a method of proving propositions or statements by inductive approach. So we have three steps here. So number one is that we need to prove that P of n, so P of n, this represents the problem, or yeah, that we need to induce, is true for some n is equal to n sub 0, wherein generally n sub 0 is equal to 1. Number 2 is that, next step, is that we need to assume that P of n is true for n is equal to k. So kanina, so the first step, we need to prove that P of n is true for some n is equal to n sub 0. So n of 0 is, from other side, they call it as the basis, or it must be equal to 1, or the basis. So that's the first step. So the second step, we need to assume that that P of n is true for n is equal to k. Next is that we also need to prove that P of n is true for n is equal to k plus 1. Therefore, after proving these three, we now arrive to the mathematical induction. So then we say that P of n is true for n is greater than or equal to n sub 0, or the basis. So to further analyze the principles of mathematical induction, let's have this example.
So for example, 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared is equal to n times the quantity of n plus 1 times the quantity of 2n plus 1 all over 6 for n is greater than or equal to 1. So we will let P of n is equal to the equation. So our first step is to prove that P of n is true for some n is equal to n sub 0, where n sub 0 is generally equal to 1. So this side is the LHS and this side is the RHS. So in LHS, we'll just get the first term, which is the 1 squared, and we will equal it to 1. So 1 squared is equal to 1, which is true. And in our RHS, so in this part, we will equate it to 1, and the second term we will equate it to 2, and the third term we will equate it to 3 all over 6. So we have 1 times 2 times 3 all over 6 is equal to 1. Therefore, in our first step, P of n is true for n is equal to 1. So let's proceed to our second step. So our second step is to prove that P of n is true for some n is equal, we need to assume that n is equal to k. So let us all change the value of n to the variable k. So P of k is equal to 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared is equal to k times the quantity of k plus 1 times the quantity of 2k plus 1 all over 6. So let's denote this as the first equation, or first equation, because we will use this later. First equation. So next is 3. We need to prove that P of n is true for some n is equal to k plus 1. So we have our equation, which is P P of k plus 1 is equal to 1 squared plus 2 squared plus 3 squared plus dot dot dot. So as you can see, na merong naidagdag na k plus 1 squared. So that's from the value na we need to prove, yung k plus 1. So for some resources, they are just copying the whole values of 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared. But actually, nanggaling yung k squared because of this algorithm. So, as you can see, di ba, sa k plus 1 squared, may naidagdag na 1. And dito is k squared. So, as you can also see here, that there is an addition of 1 per number. So, meron siyang arithmetic sequence. So, yun din ang ginawa dito. Nag-move lang siya. So, from k plus 1 squared, nag-move lang siya pa backward para ma-get yung k squared. So, that's how it so that explains kung bakit merong k squared doon. But on some resources, they are just copying the whole equation and then plotting the k plus 1 on the next number. So yun. And therefore, p of k plus 1 is equal to 1 squared plus 2 squared plus 3 squared plus ... plus k squared plus k plus 1 squared is equal to k plus 1. So, k plus 1, substituting the value of k to k plus 1 times the quantity of k plus 2. So, bakit siya naging k plus 2? Since here, if we substitute the value of k to k plus 1, we will have k plus 2. So, k plus 1 doon, magiging k plus 2. Then, also substituting the value of k sa the quantity of 2k plus 1, magiging the quantity of 2 times k plus 1 all over 6. So, next proceed. So, next is that we simplify. So, 1 squared plus 2 squared plus 3 squared plus ... plus k squared plus k plus 1 squared is equal to k plus 1 times the quantity of k plus 2 times the quantity of 2k plus 3. So, saan nanggaling 2k plus 3? So, we distribute 2. So, that would be 2k plus 2 plus 1. That would be 2k plus 3 all over 6. So, as you can see, di ba meron tayong first equation kanina. So, we will use that first equation, this one, to substitute the value of our LHS, which is ito. This one. So, our LHS is equal to this value, our first equation. So, we have k times the quantity of k plus 1 times the quantity of 2k plus 1 is equal to 6 plus this one, k plus 1 squared. So, that's our LHS. So, to continue, we need to extract k plus 1 from the both terms since parehong merong k plus 1. So, we have k plus 1 times the quantity of k times the quantity of 2k plus 1. So, extracting k plus 1 all over 6 plus removing k plus 1 here. Ang matitira is also k plus 1 is equal to k plus 1. So, we need to add these two terms. Ang kakalabasan niyan is get the LCD. So, we have 6. So, 6 divided by 6 is equal to 1 times the simplified form of this, which is 2k squared plus k. So, that would be 2k squared plus k. So, then 6 divided by 1, that would be 6 times k. That would be 6k plus 6 times 1, that would be 6. All over 6. So, we have k plus 1 times the quantity of 2k squared plus k plus 6k plus 6 all over 6. Then, we need to simplify this. So, we have this whole term. So, we have the quantity of k plus 1 times the quantity of 2k squared plus 6k plus k. Adding the like terms, we have 7k plus the constant, which is 6 all over 6. Then, if we will get the roots of 2k squared plus 7k plus 6, we will be getting k plus 2 times the quantity of 2k plus 3. So, bringing down, getting the k plus 1, we have the quantity of k plus 1 times the quantity of k plus 2 times the quantity of 2k plus 3 all over 6. So, in our RHS, actually, same lang sila sa RHS natin. But to check, we need to we need to retain k plus 1. So we have our RHS, the quantity of k plus 1 times the quantity of k plus 2 times the quantity of 2k plus 3 all over 6. So we need to retain the quantity of k plus 1. So we multiply k plus 2 times the quantity of 2k plus 3. So we have 2k squared plus 3k plus 4k plus 6 all over 6. So if we so we can see that this one is also the same with this one, and we need to simplify this. Magiging the quantity of k plus 1 times the quantity of k plus 2 times the quantity of 2k plus 3 all over 6. So as you can see, we have proven that that our LHS is equal to our RHS through P of k plus 1. So therefore, P of n is true for n is equal to k plus 1. To summarize this, P of n is true for all n is equal to greater or equal to 1, which is given on our equation. So that's it. I hope you get something.